What is up, geometry? This is lesson 8.2, or chapter 8, section 2. We're talking about Pythagorean theorem and its converse. Now I'm going to assume you've kind of already seen Pythagorean theorem, but just in case you haven't, it's for a right triangle, and if it's a right triangle, then I know a squared plus b squared equals c squared. Now these two legs, the short sides, not the hypotenuse. The hypotenuse is this one, the c. But these two legs are kind of interchangeable, so which one you call A, which one you call B, doesn't matter, as long as the longest side is that hypotenuse, and that would be C. So we can use this if we know it's a right triangle, like this one, we know it's a right triangle. We can use it, since we know two sides, to then find the third side. So for this, since these are the short sides, I'm going to say 7 squared plus 17 squared is going to equal to x squared. So it's going to be 49 plus 289, I did that on a calculator, is going to equal to x squared. So it's going to give me 338 is equal to x squared. So then if I want to find out what x is, I need to take the square root. So x would equal approximately 338. 18.38. And it keeps going there, but I'll just round it to a couple decimal places. So that's kind of the exact process you'd use if you're looking for that hypotenuse. The hypotenuse is missing here, the longest side. So you just add the squares of both of those, and then take the square root, and voila. Now this one over here is a little bit different because notice we have a hypotenuse and one of the legs, but we're missing the other leg. So what we'll do for this one is I'm going to say 22 squared plus x squared is equal to 25 squared. So it'll be 484 plus x squared plus 625. So I'm going to go ahead and subtract the 484. So then I end up with x squared is equal to the 141. Yes, I did that on a calculator. I'm being lazy. It's okay. Take the square root, and I end up with x is equal to approximately 11.87. Okay, I should say approximately equal to. Okay, so those are our two answers just using Pythagorean theorem. Now, another trick that you can kind of use with Pythagorean theorem is there are some common Pythagorean triples. Now, a Pythagorean triple are three whole numbers such that a squared plus b squared equals c squared. So 3, 4, 5 is the most common one. Notice if I take 3 squared and add to that 4 squared, that's going to be the same thing as 5 squared, because it's going to be 9 plus 16, and 25 is equal to 25. Okay, so this is a Pythagorean triple. You could do the same thing with all the rest of these as well. And the cool thing is also is that you can use multiples of them. So like if I multiplied all of these by 2, 6, 8, and 10 would also be a Pythagorean triple. If I multiplied all of them by 5, 15, 20, 25, those would also be Pythagorean triples. So if you look there on page 576 in your book, maybe something you want to bookmark, as that has a bunch of these. It has these four main ones here, but then it also has multiples of them underneath that. So what we can do is we can kind of use these to find a missing piece without necessarily going through the whole Pythagorean theorem process. So I'm noticing here 48 is 4 times 12, and also 20 is 4 times 5. So I'm going to use this Pythagorean triple right here. This is 12 times 4, and this is equal to 5 times 4. That means this one must equal to the 13 times 4, which is be 52. So I didn't necessarily have to go through the whole process. I recognize it as matching one of those Pythagorean triples, and it's kind of a shortcut method. Could I have used Pythagorean theorem and found the exact same answer? Yes, I could have, and there's nothing wrong with that. This is just kind of an idea. Hey, you want to make it go a little bit faster? If you know your Pythagorean triples, it can speed up the process. Now, the next thing is the converse of that. Okay, so Remember, Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. Well, the converse of that would say if a squared plus b squared, if a squared plus b squared is equal to c squared, then it's a right triangle. And that's what we're talking about here. So that's what this first one is here. So if a squared plus b squared equals c squared, so if I know this squared plus this squared equals this squared, then I can conclude that it is a right triangle. Okay? So if they're asking me, is this the right triangle? Well, I can find out by checking its sides to see if it fits the Pythagorean theorem. Now think about this for a second. If I kept this length, the a and the b, the exact same, and I changed it from a 90-degree angle into being something larger, so something bigger than 90 now, what's going to happen to this yellow side, the c? How would this side compare to this side? Well, I think it's pretty obvious that this side would get longer. Okay? If this side gets longer, then it's also obvious that its length squared would also get larger. So, if a squared plus b squared is smaller than that c squared, then we know that it's an obtuse triangle. Conversely to that, if I change that angle, instead of being a right angle, to be smaller than a right angle, that third side, this side, would get shorter than this one up here, than the original c, which means that the a squared and b squared would now be larger than the c squared. So if a squared and b squared is bigger than c squared, then we call it acute. So let's just test that out here. So these are three just from the book. It says determine whether each set of numbers can be the measures of the sides of a triangle, which we've covered that before. If so, classify the triangles as acute, right, or obtuse, and then pretty much show your work for that. So the first thing we're going to do is, can these be a triangle? So pretty much what I need to do is I need to check to make sure that if I add up any two sides, it has to be larger than the third side. So these two is going to be 71, it's bigger than this. If I add up these two, it's going to be bigger than that. If I add up those two, it's going to be bigger than that. So can it be a triangle? Yes, it can. So now let's classify it as either acute, right, or obtuse. So the longest one is this one here, the 61, so it's going to be my c squared. So I'm going to say 11 squared plus 60 squared, and then I want to kind of compare that to 61 squared. So using my calculator here, 11 squared is 121, 60 squared is 3,600, 61 squared is 3,771. So if I add these two on the left together, notice I get 3,721, 3,721. So notice those two are equal to each other. So that means I'm going to call this a right triangle. Okay. If we try this on the next one, we might just throw those in to estimate which one is longest. I'm pretty sure this one's going to be the longest. So I just estimated those to the nearest tenth, 3.5, 5.7, 6.7. So if I add up this, it's going to be 8, 9. That's bigger than this. If I add up these two, it's going to be bigger than that. If I add up those two, it'll be bigger than that. So do they make a triangle? They can make a triangle. So let's go ahead and use our Pythagorean theorem then. So this is going to be 4 times 3. Okay. I said that because 2 squared is 4, and the square root of 3 squared is just 3. So this squared is going to be 4 times 3. Plus, this is going to be 16 times 2. And I want to compare that to 9 times 5. This is going to be 12 plus 32. How is this going to compare to 45? This is going to be 44 compared to 45, which means that c squared is larger, right? C squared is larger. Since the c squared is larger, that means this is going to be obtuse. Because my triangle, this c squared has gotten longer, which means it has to be an obtuse triangle. Okay, so let's go ahead and check these. 6.2 plus 13.8, that'd be 14, 15, 16, 17, 18, 19, 20. So notice these two added together is equal to that one. It has to be longer. So I'm going to say no triangle can be made. So we don't have to classify that one because, well, I can't make a triangle out of it. All right. Your homework starts on page 579. You're going to do 1 through 8 all. You guys are going to do great. Good luck, guys.